Good morning, everybody. I'm Jean-Benoît Ferry from Airbus, and it will be my pleasure to moderate this roundtable. So maybe before we start, let me introduce our guest. So here next to me is Ophir Gaathon from Dust Identity, CEO and founder. Jean-Philippe Focesato, Technical Quality Manager at PSD Aero. Dominique Arnal, Senior Vice President, Raw Material and Parts Procurement at Airbus. And Pierre-Henri de Gors, Quality Project Leader at Airbus. So maybe Ophir, I think because you have experience as well on other sectors, and can you tell us more about how other areas have reacted, and tell us more?
Yeah, so first of all, thank you, and it's a great pleasure to present the work that we've done with our partners here. I would say that counterfeit is a global problem that impacts almost any industry, actually every industry that we can think of, from pharmaceuticals, where there's over 1 million people that die a year from fake pharmaceuticals. 30% of malaria drugs that show up in Africa are counterfeited, which is very unfortunate. And that's clearly a safety and human impact issue. In many sectors, like the luxury and fashion, or collectibles and art, of course, fraud exists in large scale. The difference is that I think that nobody died from a fake Gucci bag, but a fake airbag has very different implications. And I think that when we're thinking through categories where we have assets at the end of the supply chain, when we have an aircraft, a defense platform, a train, not only that we need to maintain the integrity of the supply chain and make sure that only compliant parts that are safe to use, that are available, are being deployed at the manufacturing or the assembly, but we also have to deal with the MRO or the service and the maintenance of those assets. And those tend to have maybe a double challenge with being able to secure and validate the supply chain. So if you look at microelectronics, the US Department of Defense about 14 years ago identified that there's millions of counterfeit electronics within the defense supply chain. And maybe the idea is that a $5 component can impact a $50 million asset, and not thinking through mission availability or platform availability and the impact on life.
The weak points that you see in other sectors and that you described, what are the areas of improvement? Where can we make a breakthrough on that? And by the way, is AI able also to support?
That's a loaded question, but I would say that I would like to start with the human factor, because I think that this is the greatest advantage that we have in the aviation industry, and the raw material supply chain that goes into that is the commitment of people in the quality organizations and engineering organization to safety. And we want to enable the humans to be able to have the data in their hands, whether it's a quality manager or a technician that is about to install a part. We just want to make sure that the data is available at the moment of consumption at the edge, because we need to not only support, again, the assembly, but we also need to support service operation across the world. There are, I would say, fundamental challenges that our company decided to focus on, which is really the binding of physical to digital. Because, as I mentioned before, that's where we see a lot of vulnerability. There's a QR code can replicate it many, many times. Any kind of print process is the same. RFID, NFC tags have been cloned and are not very safe and very challenging from a material perspective. So that physical digital binding or anchoring is challenging. But what we really want to be able to do is allow for efficiency to occur between the good actors and create a differentiator and provide countermeasures such that bad actors cannot penetrate. Usually, when you're thinking through a bad actor, you're thinking through maybe organized crime, state-sponsored actors, terrorist organizations that may want to jeopardize critical supply chains. they usually are not the actors that are performing the work of insertion. Usually it's people that maybe they are not knowledgeable. Maybe they don't know that keeping a storage room open overnight is going to cause any issue. Usually they're driven by financial motivation. And what we want to make sure is that we know that we can communicate to those individuals and those organizations that we know exactly what's happening. So technology like ours, and there are other technologies that people should look at as well, allows us to be able to drive the accountability towards the individual and towards the organization. I have kids, a couple of teenagers. The chance that they will complete and do their homework assignments, if nobody's going to check, is 0. I guarantee it. Like it's, and I think that what we need to be able to communicate in the supply chain is we want to know what's happening, and we want to know that you know that we know. And if there's any kind of quality or corrective actions that we need to do on retraining, that's an opportunity for us to improve. But it's also a way for us to communicate to the bad actors. We know exactly what's the name of the person, the IP address, the physical location when action was taken, and every document and every element can be verified. To your point about AI, we're using AI and we're using sophisticated algorithms. Our analysis of the fingerprint that is on the object is deterministic, so it's not using AI. It's using an algorithm that is quite accurate in being able to authenticate things like a biometric. But we use AI in order to detect fraud on documentation. The challenge that I have today with AI, and I think that as a community we're all suffering from it, is that we have to be cautious and calibrated and knowledgeable about the tools that we're deploying. If any of your organization will consider the use of AI for operational or security applications, how long do you think it will take for your organization to accept that solution? Anybody thinks that it will be done faster than 5 years? Can people raise hands? Anybody thinks that it will take more than 15? Anybody thinks it will take 10? Okay, thank you. I appreciate that you raise your hand. Maybe the punchline is that when you're thinking through AI deployment, you have on one side a bad actor that takes the tools today and use them immediately. And if it took several weeks to generate back to birth documentation by somebody who's trying to forge the story, because they had to type, they had to add some analog noise to the documentation. Today, you do it with a single prompt. So the ability of the bad actor to use AI is unfortunately advancing much faster than our ability to deploy AI in order to provide countermeasures. So I think that we can use it, but I think that we need to be able to adopt much, much faster and have a layered-based approach that will allow for faster deployment of.
As a security practitioner, I think that you have to have a layered-based approach. You have to have an understanding that the attack surface is changing. So any kind of assumption that you'll be able to install at a specific time a solution that will be resilient for decades is just incorrect. And I think that that's where, not only that from an adoption of capabilities that it will take time to go through transformation, you also need to have this continuous development and continuous evolution of your solutions, because the other side is doing the same thing. So in the same way that when you're thinking through cybersecurity concerns, the concerns that we have today is with agentic attacks, so AI attack on systems. That was not something that 10 years ago, 5 years ago, people were concerned with. So I think that it's very important that, one, you have diversity of solutions. One can be ours, but definitely not the only solution. And we need to be resilient to any kind of changes in the way that the bad actors, nation-sponsored actors, are trying to manipulate or impact the supply chain. So I don't know if it makes sense, but I think that it's always good to have a plurality of solutions that are stacked in a way that gives you that coverage. We design our solution to have that open architecture. So, for example, the solution that Airbus is supporting on Decadex, which is being able to provide a decentralized way to ensure that data integrity across the digital thread is sustained. These are partnerships that we look forward to form. We don't believe that you can have a single solution. Dust is not magic dust. And there are no, I think, one solution that can fit all the different things that you need to be able to support.
Can you give us a little bit background, if you can do that? It would be appreciated about this technology. Thank you.
Absolutely. By the way, we have a booth downstairs, so you're welcome to actually see the technology in action, and we can provide a better explanation. We are not providing an additive to the material. So because of concerns with change of formulation and impact on the purity of materials, and also the versatility of what we need to be able to protect for a client. So when you think through an aircraft like the A320, the variability in geometry, materials, form factor, surfaces, thermal schedule is so diverse that when we approach those type of problems initially when we came out of the university, it was really focusing on how can we provide this digital physical anchoring in a way that is very easy to apply across the value chain, including in field operation. And that's where it's a top surface application. We use diamond dust that are encapsulated inside an epoxy. That epoxy is usually coming as a material that the OEM or the client is providing us, because then it's gone through all the durability and understanding of their fatigue schedule. So all we need to do is incorporate a little bit of diamond dust into that material, and then it goes through a qualification process that is very similar to a 510K for medical. It's a proof of equivalence rather than being able to demonstrate the efficacy of the product with a little bit of dust. So I can spend hours talking about that, but you're welcome to join us in our booth right after this.
I'm curious how you manage the traceability from, say, a finished part back to, say, ingot, scrap, sponge, because how can you trace sort of a blade back through? Obviously, the marking on a sort of product is okay if it's on the end of a billet or something, but what if that's cut off or forged? I think that kind of lends into the previous question. But then even going further back to the raw material, how do you integrate that? And for Airbus as well, how do you manage that looking at your own raw materials supplies?
The proof of concept that has been run from the melted product. I would even say from the rolled product to the part being delivered to Airbus. So there has not been traceability at the stage of scrap and sponge, and I think now it depends on the various players, and now I can only speak for Airbus. We are not within Airbus qualifying the sponge per se. We give this responsibility to the melting guys. So that's, I think, partially answering your question. I think you want to complement.
Yeah, maybe more on the technical side of we have a raw bar that it's maybe 6 meters, and then you cut it into pieces. In that process of cutting or any kind of transformation, physical transformation to the part, there is an opportunity to remark. And the idea is to drive again back to the accountability of the entity that is providing that transformation. So if it's a contract manufacturer like let's say Mechachrome received raw bars from PSD. The raw bar had marking at the end where usually the marking is, complementary to the existing marking that PSD is already providing. And then Mechachrome sliced a wafer to do quality check, and that was marked. And every segment was remarked at Mechachrome. The ability to mark things and make sure that you can make a claim or an attestation towards it, that's one of the things that we want to enable.
problem that we have, or some of the challenge that we see in the aviation industry is that part marking, if you're thinking through the regulatory component, is only on the finished product. So the ability to track things usually is followed with a traveler or some kind of piece of paper. Usually the part is sitting on some paperwork in a manila envelope. We want to be able to change that such that there is a good way for a machinist, a quality practitioner, somebody that works in the warehouse to mark anything that they need. It could be a crate. It doesn't need to be the raw bars themselves. Very easily, and then attach a claim that is attached to their identity. And by providing the connection to the identity of the individuals and the organizations and the location, we hope that we can displace the motivation or increase the complexity for a bad actor to influence. Because the minute that we're moving between an org or organization level of traceability to the individual traceability, of course, with all the privacy concerns that need to be accounted for, we can drive the individuals to know your name is on the bar, your name is on the part, and therefore, if we're going to find that there's any kind of quality issues or potential manipulation of the documentation, we can go back and verify with the individual what happened.
If I may add something related to the proof of concept that we have done, it's just a proof of concept, was for us important to have a way to demonstrate that we could associate at the different step of the industrial process, at least the ones that Airbus qualified. So it comes back again to the first question that Jean-Benoît was asking me, qualification and certification. So we start to qualify a bar, a plate, sheet. Okay, then it's let's say transported, machined down to the parts that we are installing in our aircraft. So the idea was to associate in a unique and non-alterable way the documentation from the plate. Okay, to be sure that the certificate of conformity was correct, and then subsequently information added about who has manipulated this part, distributor, who has machined this part, certified, qualified or not, and then mounted in our aircraft in a unique and non-alterable way. This was the idea of the proof of concept that we have done and successfully done.